Hi everyone, in this video, I'm going to show you how to sketch the basic trigonometric graphs, sine, cosine, and tangent, and their transformations using Desmos. First, let's start by setting the angle unit. Go to the Settings menu in Desmos. And here you can choose between degrees and radians. Make sure you are aware of which one you are using because it affects the period and the way the graph appears. This time I'm going to use degrees, and I change the x-axis from 0 to 360 degrees. The step is 30 degrees. And change the y-axis, for example, from -5 until 5. And the step in every 1 unit. Let's begin with the basic function y equals sine x. This is the standard sine graph. It has amplitude 1, period 360 degrees or 2 pi, and it oscillates between -1 and 1. Now compare it with y equals negative sine x. This graph is reflected across the x-axis. Next, let's look at y equals sine 3x. The number 3 affects the period. There are 3 waves. Can you see the difference between the blue and the red one? The new period is 120 degrees or 2 pi over 3. 120 is of course from 360 divided by 3. Now let's change the amplitude. Y equals 2 times sine 3x. The graph stretches vertically. The amplitude is now 2. Next, apply a vertical translation. Y equals 2 plus 2 sine 3x. The whole graph shifts upward by 2 units. The midline is now y equals 2. And the graph ranges from 0 to 4. Now let's try y equals sine 2 over 3x. This time, the graph stretches horizontally, so the period becomes longer, which is 540 degrees. Let me change the x-axis from 0 to 540. To make sure you understand, you will see one full wave. Can you see it now? Now I multiply this function by 3. This increases the amplitude to 3. Now translate it downward by 1 unit into y equals 3 sine 2 over 3x minus 1. The midline is now y equals -1. Now, do you understand how to sketch the graph of sine function? Next, let's move to cosine. Start with y equals cos x. This is similar to sine, but it starts at its maximum value. Next, y equals cos 2x. The two coefficient of x affects to the period. The period becomes shorter, which is 180 degrees or pi. 180 is from 360 divided by 2. Now increase the amplitude, y equals 3 times cos 2x. Then reflect it, y equals -3 cos 2x. This flips the graph across the x-axis. Now translate it upward 2 units. The midline is now y equals 2. Now let's look at the tangent function. Start with y equals tan x. This graph is different from sine and cosine. It does not have a maximum or minimum, and it has vertical asymptotes. The period of tangent is 180 degrees. or pi. The asymptotes occur at 90 degrees. That 90 degrees is actually from half of 0 to 180, distance from 0 to 180, which is 90. If I add more values on the x-axis, for example until 360 degrees, we can see that now we have two waves of tan graph. One more asymptote line on 270 degrees. 270 is from the midpoint between 180 to 360. Now try y equals tan x over 4. This stretches the graph horizontally, so the period becomes 720 degrees or 4 pi. Let me change the x-axis into 720 degrees. So you can see clearer that this graph is similar to tan x. The 720 from 180 divided by 1 over 4 or 180 times 4. Next, I multiplied the function by 5. This makes the graph steeper, a vertical stretch. Finally, translate it upward. The whole graph shifts up by 1 unit. Where is the asymptote line? Of course, the midpoint between 0 to 720, which is x equals 360 degrees. I changed the y-axis value from negative 10 to 10 to make it clear graph. Yeah, and that's how we can explore transformations of sine, cosine, and tangent functions using Desmos. Try changing the values yourself to see how its transformation affects the graph.